We're going to talk about 8.3, solving systems by Gaussian elimination. This is kind of a combination of 8.1 and 8.2. We're using systems of equations, and we used the elimination, also called the addition method, when we were solving systems of equation. And now we're going to take those and put it into a matrix and see how we can use that matrix setup to kind of make the notation a little bit easier. It's almost exactly the same thing as when we did elimination just with the equations. It just looks slightly different. So what we have to do first is set this up as a system of matrices. We talked briefly about this at the end of 8.2. So we took all our coefficients and put them into a matrix, lining up all the rows and columns. Because remember, a matrix is just a data storage system where we put our numbers into some kind of array, into a rectangular array. And then we had our variables. In this case, we're using x1, x2, and x3. And then our answers, 9, 1, -3. Now, we looked at setting this up in 8.2, so make sure you remember how to do this and why those two are equal. Today we're going to talk about something a little bit different, though. We're going to look at an augmented matrix. An augmented matrix is where we take our coefficient matrix and we write it out. And then we put a line and put our answer matrix. So it's been augmented, made a little bit bigger by smushing those two together. When we do this, we can use Gaussian elimination so that we end up with some zeros here, and we end up being able to solve our equations with substitution and get our answers with that. Now, like I said, it's just like when we used elimination with the equations. It's just a little bit easier on the notation. So let's try an example. Let's say we have a system of equations that looks like this. We're going to start out easy with just two equations, two variables, two equations. So what we do first is we write our augmented matrix. So that's the coefficients and then the answers. Now, we're going to do just like we did with elimination when we were just using the equations. What we want to do is change this so that we end up with a 0 here so that we can solve this. So what we're going to do is we're going to multiply row 1 times -4, and we're going to end up with a new row 1. And we still have row 2. And some of these you can combine your steps. You don't have to write out each individual step, but I'm going to write out each individual step to help you see. And then we'll leave row 1 as it is. And we're going to add the new row 1 plus the row 2 to get a new one. And we have 0, -14, -14. So we added these and got 0, -14, -14. Now, this gives us enough information. So now we have -14y equals -14 from this here. So that gives us that y has to equal 1. And of course, we can take our y has to equal 1 and plug it back into one of our equations up here. And we get our x equals 5. So our answer is 5, 1. So all we did here is exactly the same as doing the addition method and the elimination method, whichever you want to call it. We're just writing it out in matrix form instead of writing it out with all the equations. So let's try another one. Let's try one that's a little bit more complicated this time. So we have x plus y plus z equals -2, and 3x plus 2z equals 0, and 5y minus 3z equals 4. So the first thing we do is we write out our augmented matrix. So we have all the x's, x's, x's. Make sure you're careful about how you do that. And then we have y's, 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 and z, 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 our line, and then answer, answer, answer. So there's our augmented matrix. So now what we need to do is get it so that we can solve these equations. So the first thing we're going to do is, looking at my notes here, trying to figure out what I did. Oh, yeah. Okay, so the first thing that I did was I switched these two just so I could have this 0 up here so that it looked more like the elimination that I was used to. Now, are there multiple methods to get to the same thing? Of course. There always are. Now, to get this third row, what I'm going to do is I'm going to have -3 times row 1. I'm going to add it to, if this is row 1, row 2, and row 3, then I'm going to add it to row 2. So if I have -3 plus row 1, then I've got, that adds together to be 0. -3 plus 0 is -3. -3 plus 2 is -1. And 6 plus 0 is 6. So here's our new matrix. Now, next step, what am I going to do? Well, I'm going to leave these first two rows alone. And remember, we're looking for ways so that we can solve one of these equations for one variable. So we need zeros in this, and so that we have zeros in one of these rows and two of the columns for one of the rows so that we can solve that. So if we take, let's call this our new row 1, row 2, row 3. If we take row 2, the new one, minus 3 times row 3, so we say 0 minus 3 times 0, that gives us 0. And then 5 minus 3 times -3, so that's 5 plus 9, which gives us 14. And then -3 minus -3, so that gives us 0. And then 4 minus 18, which gives us -14. So you see here now we've got a 0 in two places. So that means we have one of our variables solved for. Remember, the middle one is y, so that means we have 14y equals -14. So y equals -1. So then we can look at this equation here where we have 5y minus 3z equals 4. So 5 times -1 gives us -5 minus 3z equals 4. Add 5 to both sides. So divide by -3. And then here in this last equation, we have x plus y plus z equals -2. So we can say x minus 1 minus 3 equals -2. X minus 4 equals -2, which means x equals 2. So our answer is 2, -1, -3. Could we have solved this by elimination without setting them into the matrices? Of course, but that doesn't necessarily, it's not always necessarily the easy way. Sometimes it's easier for notation purposes to just have to deal with the numbers and not worry about all the letters. Like I say, it's the same exact thing we did in 8.1. We're just writing it a little bit differently. It takes practice, because there's lots of different ways we did it. Do we have to switch these rows first? No. Did we have to add it and subtract it this way? No. We could have done whatever it took to end up with 2 zeros in one of the rows so that we could have solved that one and 1 0 in the other one. So we could have solved that one. And we just work our way backwards, just like we did with the equations. Now, just like with the equations, sometimes you're not given everything that you need. For example, if you have 3 variables, then in order to get the exact answer, we need 3 equations. But if we only have 2 equations, we're not necessarily going to be able to get an exact answer. What we get is a general solution. We talked about this a little bit with 8.1. We can get a general solution. So what we're going to do is we're going to say z equals t. That's our starting point for our general solution. So all we need now is if we put this in our matrix, now we already know what z is, so we only need to get a 0 in one of these. So what we're going to do is rewrite the first one, and then we're going to say 2 times the first row plus the second row, because that'll give us, see right here in the y's, 2 times 3 is 6, and then negative 6, that'll give us a 0. That's what we want. And we end up with 7, 0, 4, and 29. So check that. 4 plus 3 is 7, 6 plus negative 6 is 0, negative 10 plus 6, let's see, did I do that wrong? Negative 10 plus 6 is negative 4, and then 36 minus 7 is 29. So now we know that z is t, so we have 7x minus 4t equals 29. So 7x equals 4t plus 29. So x equals 4/7 t plus 29/7. Make sure you're checking my math for careless mistakes here. Now, we got a whole load of fractions, so that doesn't make it any fun, but we've got to plug it in here. So we'll have 2 times x, which is 4/7 t, plus 29/7. And then we don't know what y is yet, and we know that z is t. So we multiply this, we have 8/7 t plus 2 times 29 is 58. And then plus 3y minus, now we know we're going to need this to be a 7th so that we can put them together. So we're going to just go ahead and do that. And we also know this one, we need it to be a 7th. So we're going to go ahead and multiply that. So 8 times 7 is 126. So we end up with 8/7 minus 35/7 is 27, right? Negative 27 over 7t, and we still got our 3y over here, equals, and we can subtract the 58 over there, and we end up with 68/7. Make sure you're checking me for mistakes here. And then we can add the 27/7 t over here, and then divide by 3. And there's our y. So our answer is 4/7 t plus 29/7. And 27 over 21 t plus 68 over 21 and t. So there's our answer. When you're asking for a general solution, the best way to start is just let one of them equal t. And it may not be pretty, but That's the general solution. We'll go over some more of these in class, spend a couple of days on this and make sure we've got it. Make sure you've read the section thoroughly, taken lots of good notes, and have plenty of questions to ask so that we can make sure you've got this down solid.